Hey everyone, my name is Nadine, and I'll be the event supervisor for cryptography this year. And I'm currently a first year at Harvard. This event falls under the category of technology. And so the test will be open book, open internet, and even open Python. So for the code that we use in this test, we'll release it like at least a week prior to the competition to allow you to have time to prepare or learn any of the functions in it. And so next we'll go into the topics that we'll cover in the next few weeks and that will be on the test. The first one is background knowledge in math, and specifically number theory. So we'll go over modular multiplication, multiplicative inverses, and understanding Fermat's little theorem, enough so that you can use it for RSA Euclidean algorithm for finding GCP. And the second is programming with Python. And so we want you to understand the code that we'll have on the test and that we will release prior, and also to be able to write code to perform some of the tasks that we ask you to do, and just to be comfortable with hexadecimal representation of integers. That will really help in your code. And so the next main topic is public key encryption, and mainly RSA. So first we'll ask you to encrypt and decrypt messages using the provided Python code for RSA, break an encrypted message given a small public key, be able to construct an appropriate public-private key pair given 2 primes, and lastly, to understand the strengths and weaknesses of RSA. For example, some known factoring algorithm problems. The next topic will be elliptic curves. So understanding elliptic curves are the real numbers and integers mod p as a group, and also understanding Lenstra's elliptic curve factoring algorithm. And don't be scared if you don't know what any of these are at the moment. We'll definitely go through all of them in the next few videos and lectures to come. The next topic will be Diffie-Hellman Key Exchange, where you will need to know the standard and ECDH, and also to determine public messages sent between 2 parties for Diffie-Hellman given private key. And secondly, we have also digital signatures and attacks. So we'll learn how to create and verify or falsify digital signatures using RSA or ECC. And also another important aspect will be to understand common attacks on both RSA and ECC, like algorithms for factoring numbers or algorithms for the discrete logarithm problem. And lastly, it will be important to know about different internet protocols. So we'll go over SSL, TLS, AES, PGP, HTTPS, and SSH, and also WEP and WPA. And so that's it for all the topics on this event, and we'll be going through them in the next few videos. And there's going to be a lot of math, a lot of Python, a lot of encrypting, a lot of decrypting. So I hope you're just as excited as I am.